9 students took the SAT. Their scores are listed below. So we have 9 students who took the SAT, and we list their scores right there. Later on, they took a test preparation course and retook the SAT. So the same students went through tutoring and they did another test preparation course and retook the SATs. These are the new scores after doing a test preparation. Tests that claim that the test preparation had no effect on their scores. Okay, first of all, guys, you have to do, what does it mean, no effect on their scores, guys? Can someone explain it to me?
Equal to or not equal to?
Yeah, it didn't make a difference. That's what it means. Like I got 740 on the first attempt. I'm going to get 740 on the second attempt. That's no effect. So equal 0, not equal 0. Exactly. Even when I do the differences, guys, you're going to see some numbers, positive, negative. That has nothing to do with the claim. The claim, it says no effect. That means 0 or not 0. So let's do the difference here. If you do the difference, just let's put D here. 720 minus 740 is negative 20. 860 minus 860 is 0. That's a 10. That's a negative 40. 860, that's a negative 30. 710, that's a negative 10. 850, that's a 10. The students did not improve. 1212.40, that's a negative 40. And 950 minus 970, that's negative 20. This is your L1, guys. You can see I've done the work already right there. So let's put it in L1. Stat, edit, comma, L1. And let's put the data in there. Negative 20, 0, 10, negative 40, negative 30, negative 10. So maybe the test did make the difference, and we're not going to be able to support what we're trying to prove here. Negative 40, negative 20. So maybe we will reject the claim. All right. And as you notice, guys, no effect means equal to 0. That's what, no difference. No difference means equal to 0. So this is why the claim is right there. And that will be not equal to 0. So you just go to stat, t-test. And against 0, always against 0. If you ask me here, it's going to be always 0. And then you choose different from right there. And hit calculate. And that's T. T is negative 2.4009. So negative 2.4. Right here, guys, you can see it's the exact same screen that I got. And the p-value is 0.043, which is less than 0.05. So we reject HO. So p-value less than alpha, reject HO. And you say there is sufficient enough evidence at the 0.05 level of significance to reject the claim. And that is the conclusion of the problem. So we're rejecting the claim, so we're saying the claim is false. So probably the test is making a difference. As you can notice, guys, many students did improve when they did the test preparation. The students improved by 20 points. The students improved by 40. The students improved by 30. The students improved by 10. The students improved by 40. That improved. So it was improvement. It's just didn't. So making no difference. I think that was a false claim. And that's why we ended up rejecting the claim. Okay, guys. So this is another exercise from section 8.3. Let's see. Let's do question 1 right here. Dr. Smith would like to determine if there is statistically significant difference between her 2 Math 1800 classes. To make this comparison, she will compare the results from exam 1 class from exam 1. Class 1 had 33 students take the exam with a mean of 82.6 and a population standard deviation. You see, it says a population standard deviation, guys. So what does this tell us? That we have to use what kind of test?
Z.
Yeah, that's exactly what I'm trying to show you. We need to use the z-test. So let's put the information. Class 1. N1 was how many students? 33. X1 bar was 82.6, and sigma 1, guys, because it says population standard deviation 1.41. Let's go to class 2 now. Class 2 had 31 students with a mean of 84. So X2 bar is 84. And a population standard deviation, guys, it says 3.63. Can Dr. Smith conclude that there is a difference in the mean test grades? Well, it's obvious, guys. This is difference. So it's going to be this. Mu1 equals mu2. Mu1 not equal to mu2. And that's the claim by the teacher. And as you said, guys, it's a 2-sample z-test. Let's run that 2-sample z-test and we should be all set. So stat, tests. It's number 3, guys. And it's not data, it's a stats. Sigma 1, 1.41. Sigma 2, all right, I have it right here, guys, 3.63. X1 bar, 82.6. X2 bar, 84. Oops, sorry, that's N1. So X1 bar 82, N1 is 33, X2 bar is 84, N2 is 31, and we need to test that they are different. And I can do a draw if you like. Watch. Let's see what the p-value is. So Z is negative 2.01, and p-value is 0.0445. That's question 1. So Z is negative 2.01, and the p-value is 0.0445. And let's see what alpha is here. Alpha is 0.05, guys. So it's less than alpha. So reject HO. And you start. There is enough evidence at the 0.05 level of significance to what, guys? The claim is in H1, HA.
Support.
Yep. To support the claim made by the teacher. And that concludes the question. So we have enough evidence to support the claim by the teacher, Dr. Smith. There is a statistically significant difference between the two math scores. You can say that. Okay, so that's number 1. Number 2, a survey found that the average hotel room in New Orleans is $88.50. And the average hotel rate in Phoenix is $84.75. Assume that the data were obtained from 2 samples of 55 hotels each, and that the population standard deviation were $5.60 and $4.83. So he says population standard deviation, guys. You're stuck with z-test here. So question 2, we have New Orleans, and we have Phoenix. We have N1 is 55 and N2 is 55, he says. We have X1 bar, the rate to be 88.50 cents, and the rate in the other city to be 84.75 cents. And we have sigma 1 is 560, and sigma 2, guys, is 483. And if you ask me again why I put sigma and sigma, I didn't put S1 and S2 because he says population standard deviations.
Can you move your paper up, please?
Yep, of course. There you go. Can it be concluded that the average hotel room in New Orleans cost more than in Phoenix? So guys, which one is it gonna be? New Orleans is number one. Let me show you the three scenarios. Which one you're gonna choose? 1, 2, or 3? New Orleans is more than Phoenix.
3.
3. I agree. Couldn't agree more. HO. Exactly, guys. That's the idea. That's the claim. Okay. It's a 2-sample Z test again. So I tried to put 2 questions from section 8.1 here to review this. And let's run the test. If we were doing the work by hand, guys, it wouldn't even be halfway through of what I got done. That's what we used to do a while ago. So sigma 1 is 5.6. Sigma 2 is 4.83. X1 bar is 88 and 50 cents. N1 is 55. X2 bar is 84.75. What do you think, guys? Do you think New Orleans cost more? I mean, it's $3 difference. I don't know if we can approve of this. Let's see, 55, and that's greater than. You always have to ask, is the difference is statistically significant? Is it like, or practically significant? If it is a $1 or $2, maybe people wouldn't like look at it as really that there is a difference. Okay, let's do a draw here. And let me show you. It's coming. Okay, Z is 3.76, and the p-value you can see E1, E minus 4. And the p-value, here's how you write it down, guys. 1 E minus 4, you just move the decimal 4 digits to the left, so it will be 0.001, which is of course less than alpha. Right away, you can conclude it is less than alpha once you see the E. So reject HO. We reject HO because the p-value is less than alpha. And we say there is enough evidence at the 0.05 level of significance. Who can give me the magic word here? There is enough evidence to what?
Support.
Support the claim. We are supporting the claim here. We're not saying there is not enough evidence. We're saying, yes, so New Orleans cost more. That's what the conclusion, guys, is here. So that's question 2. Okay, let's go to question 3. Real estate. So these for section 8.1, the first 2 questions. I think these 2 for section 8.2. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the value of a home. A random sample of the 2 groups appraised 10 homes. Is there a significant difference in the values of the homes for each group? Let alpha equal 0.05. Assume the data are from normally distributed population and that population variances are not equal. This means pooled is no, guys. Now, how do you know it's a t-test, guys? First of all, even without looking at this is a hint that it's a t-test. Look what he put here. He put S1 and he put S2. Once he mentions S instead of sigma, it is a t-test. So that's another hint for you guys to know the difference between t-test and z-test. Okay, which hypothesis you're gonna pick for me here? He says, can you conclude that there is a significant difference in the values of homes between the 2 assessors? 1, 2, or 3? What do you guys think? I got the chat. Okay, let's see what the chat. Oh, it's always samples, but when he gives you S, it is a t-test. Look, he says S1 and S2, whereas in the previous question, he says a population standard deviation, which is sigma 1 and sigma 2. So do you guys agree it's going to be number 1 here, mu1 equals mu2, mu1 not equal to mu2, and that's the claim in HA. And it is a 2-sample t-test. Again, the big hint for you guys when he says assume population variances are not equal, that's a pooled, and pooled only exists in t-test. So we're going to do a 2-sample t-test, and let's see. Stat. It's number 4, guys. There you go. Let's enter the data. Okay. X1 bar, $83,256, the appraiser, with a standard deviation of $3,526, and we had 10 homes. And then the tax assessors, $88,354. S2 is 2,341, and N2 is 10. We're doing not equal to, guys. There is a difference. We're saying, and look, pooled now. It says not equal means pooled is no. Look, you have to select it. Select it. Don't let the gray part on the yes. It has to be on the no. And then calculate. Okay. So T is negative 3.809, and look at the p-value. It's very small, guys. That's all I need.
So with the t-test, the 2-sample t-test, that's the only one that is going to ask about being pooled.
Exactly.
Okay, so that can be another.
And the hint, and as I said, the hint is right here. When he says at the very end, assume population variances are not equal or equal, right away you should know it's a t-test. It's a 2-sample t-test. So if you were tempted to use the z-test, don't do it, because he's giving you some information you only can use with the t-test. Does that make sense? P-value is 0.0016, which is less than alpha, guys, and we reject HO. When the p-value is low, HO must go, so we reject HO. And the conclusion. I forgot here to put the claim right here. There is enough evidence at the 0.05 level of significance to what? The claim is in H1, HA. So the word will be what? Support the claim. And just copy and paste the claim that there is significant differences in the values of the homes for each group. You know, tax assessors, they try to raise the value of the home because they want to charge us more taxes. So I agree that there is always a difference between the two.
Professor, I got a different answer for T.
Did I put something different? Let me see. Stat, tests. Well, at least good. Some students are following with this. Let me see what I put. So 83,256, I can double check, no problem. 3526 and 88354. 2341 and 2 is 10. And did you choose pooled no or yes? Probably you did yes.
No, I put no.
Because that should be, look at my screen, they should match. So double check the work. And here you go. I get the same numbers again. Negative 3.809. Yeah. Number 4. Last one. And that concludes the chapter. Number 4. Let's do it together. It's again a 2 test. A researcher suggested that male nurses earn more than female nurses. A survey of 14 male nurses and 22 female nurses reports these data. So we have 14 males, and he calls the females N1 here, and 22 females. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equal 5%, assume data are normally distributed and that population variances are not equal. That means pooled is what here, guys? No.
No.
I think that should be a hint for you that it's a 2-sample t-test. All right. He's asking, can you support the claim that male nurses earn more than female nurses? So let me just put this right here and ask you which one would you choose? 1, 2, or 3?
3.
All right. You chose 3 because it has more than, correct? That's a more than.
Yes.
But remember here, he's asking if male nurses make more than female nurses, but look what he did with us here. He labeled the females as what? 1, and the males were second as 2. And we need to obey by this and respect, the ordering. He says, I want you to call females as number 1 and males as number 2. So now, guys, if you want to do 1 to 2, if males make more than female nurses, that means female nurses make what?
Less than.
Less than. So it's going to be a less than. And look, guys, one thing we should give you a hint. Look, this is 23,750. This is 23,900. This is the only question, guys, where the language here is opposite to what it is there. Here, I started with male earning more than females, but I put the females as labeled 1, and I labeled the males as 2, just to bring it to your attention so you can be careful. I mean, I could have said here, is there enough evidence to support the claim that female nurses earn less than male nurses? And then that will be straightforward. I could do that, but just to show you that sometimes you have to be very careful with the language. So we need to check that. Female nurses earn less than male nurses, and that's the claim. Okay, and it's a 2-sample t-test, guys, and watch. Stat, 2-sample t-test. X1 bar, 23,750. I think nurses make a lot more than that. $250, and 1 is 22. So these are the females, guys. Now the males. 23,900. S2 is $300. And 14 male nurses. And we want to check if females make less than males. So less than. And pooled is no, guys, right here. And let me just do a draw and see what we get. Oh, it's a large p-value. See, the p-value is shaded to the left. It's the area to the left of the test statistic. So negative 1.558, and the p-value is 0.0661. And alpha is 5%, so that's bigger than alpha, guys. That's bigger than 5%. So fail to reject HO. And finally, guys, there is not enough evidence at the 0.05 level of significance to support the claim that male nurses make more than female nurses. That's not true claim. Make more than female. So if the female nurses make a case with this hypothesis test, we'll tell them, well, sorry, we cannot support that male nurses make more than you. So because we said we perform a hypothesis test. Okay, so